Welcome. This series is designed for developers with basic Python knowledge who want to move beyond simple scripts and build a sophisticated multi-agent systems. While I explain the code using LangGraph and also the concept of parallel orchestration, I will try to explain concepts from basics. By end of this course, I'll make sure you have fully functional AI content agent. By end of this course, if you find this valuable, please make sure to subscribe for more interesting videos on agentic workflows. Let's assume I'm a social media creator. My job is to create a tweet for Twitter, a post for LinkedIn, means basically an article for LinkedIn, and also few posts for Instagram. So each platform needs a different type of a content, although on the same topic. Okay. So I want my AI model to provide me a tailored content for these platforms. Okay. I want this platform, or sorry, not a platform. I want this AI model to generate the content parallelly. Okay. So I don't want basically something like first it generates for LinkedIn, then it generates for Twitter, then it generates for Instagram. I want task parallelly. This type of framework known as parallel orchestration framework in LangGraph. Okay. This is achieved using via fan in and fan out concept, or we can also call it as a map reducer pattern. So by end of this tutorial, I will make sure you have a solid understanding of what is parallel orchestration, the concept of send and command, and why they are used in LangGraph, as well as the concept of LangChain. Node, planner node. Yeah, let's call it as a planner node. So a user has requested a planner node that I want to write a content about India 2026 World Cup. I want to post it in LinkedIn and Twitter. So planner node will send this. Okay, not the planner node, input node. Let's call it as an input node. Okay. So this is the planner node. Here on the input node, we will use an LLM. The job of this input node is only to understand the intent of the customer and to give us an output on which platform the user wants to post. And it will pass this to planner node. Okay, good. Planner node received the request. So there are nodes which are already available. Okay. Let's call it as LinkedIn content generator. This will be Insta content generator. This will be Twitter content generator. Planner node will check on which platform does the user wants to generate a content. We'll go here, this. Okay. Then from here, I'll go again to, okay. So planner node will check if suppose as I wanted to have in LinkedIn and Twitter only, then planner node will make sure that only the LinkedIn and Twitter nodes get executed. So here it is spreading to all three, okay, as a three. So this is known as a fan out concept, okay, and this is like a map. Fan out is spreading out, or the map is like from one node you have three paths to go, okay. Now the planner node, based on the condition, it will execute those functions or those nodes, okay. Basically we'll be calling an LLM on this node. Okay. And then there will be okay. So this will be end. I'll call it as an aggregator. Basically, the job of this node will be to aggregate the data from these three nodes and to show it as a one. Okay. Because I want an output as LinkedIn. This is the content. For Twitter, these are the tweets. For Insta, this is the post. Basically here I want a single source of visibility to the user. So from here, I will go and add this. So you see, even these three, as they're fanned out, here they're fanning in. Okay, means they're getting inside. And also in a simple term, they are reducing it to 3 to 1. Okay, so this is known as the mapper reducer pattern, or fan in, fan out, and fan in concept. And the aggregator will make sure that you are showing it as a single response. And from there, okay, this is what we'll be trying to build. As part of the development, I will be using VS Code to write Python code. Then we'll be using UV to run Python project. Okay. And we'll be using LangChain, concept of LangChain. LangGraph, send command keywords. To create an agent, we'll be using chat init model. And also, I'll try to show the create agent as well, the both chat init model and create agent. I'll try to cover. And chat prod template. For LLM, I will be using Groq. This Groq is basically a LPU based platform company that hosts multiple model on its infrastructure. I will use this platform to call one of the models available on their system. As once you have signed up successfully or logged in, you can use create API key to generate an API key, because we need this API key to call this platform and to use an LLM model. These are different types of model available. So first, create a folder and open it in a Visual Studio Code, or basically you can create a folder directly or directly from the terminal as well. First, I will be initializing the UV project. Okay. Then UV sync. Basically, UV sync will create a virtual environment directly. Source, I need to activate the virtual environment, which I'm doing now. I'll be creating two files. One, requirement.txt, where all the packages which I'll be using as part of this module, I'll be adding it here. And .env. It has created both the files. Now, let's go to the LangChain document of chat Groq. Okay. Basically, to call, to provide an API key, we need this naming convention particularly. So I'll be adding this .env. Okay, what does this do? By using this naming convention, LangChain will be able to understand that, okay, this is the API key of the Groq, which it will use it to call the platform or to send a request to the platform. Please use the API key which we had generated earlier. Basically, that will be the format GSK. I will copy my API key. Okay, I have added my environmental variables. Add a few of the packages which we need. And also we need the chat Groq. So this will be the at least for the initial start, these are enough. Let's activate these packages. So we have successfully installed the packages. So let's start. Let us create one notebook. Mapper IPYNB. It will be the form extension basically to run it as a notebook. So I'll be loading the environmental variable first from dot env import load dot env. I'll run this. So I need to select my Python environment. Okay, perfect. It has run now. Okay, now let's go back to what we are trying to build here. User provide an input to an input node. I want my input node to provide me a structured output. When I say structured output, take the example of this. User had provided input. I need to write a content about India 2026 World Cup win. I want to post it in LinkedIn and Twitter. Okay. So I want my LLM to understand the intent of the user. I want my input node to return me, or basically the LLM of the input node to give us user requested, write a content about India 2026 World Cup win. LinkedIn true, Twitter true, Insta false. Okay. So we are expecting a structured output. To achieve this, we will be using chat prompt template and init chat model.